In this lecture, I am going to present what is beam, what are the different types of beams, what are the different types of load acting on the beam, and what are the different types of support, and what is the static equilibrium equations, and how to determine the static indeterminacy of a beam without or with internal hinge. A beam is a one-dimensional structure. It carries their loads by developing bending moment and shear forces at different sections. There are different kinds of beams: simply supported beam, cantilever beam, prop to cantilever beam, fixed beam, and continuous beam. Simply supported beam. When the beam is resting over two supports, so this is called the simply supported beam. So here one support is hinge support and another support is roller support. The beam is resting over the hinge and roller supports. So this type of beam is called the simply supported beam. And cantilever beam. When one end of the beam is fixed and other end is free, so this type of beam is called the cantilever beam. Then prop to cantilever beam. So when one end of the beam is fixed and the other end of the beam is supported, then this type of beam is called the prop to cantilever beam. Then fixed beam. So when both ends of the beams are fixed or built in, so this type of beam is called the fixed beam. So here this end is fixed and the other end is also fixed. Both ends are fixed. So this type of beam is called the fixed beam. Then continuous beam. When the beam is resting upon more than two supports, so this type of beam is called the continuous beam. Here the beam is resting more than two supports, that is three supports, that is over three supports. So this type of beam is called the continuous beam. Then coming to the different types of loads which is acting on the beam. So this is the simply supported beam. One end is hinged and other end is roller support. So here this type of loading is known as the concentrated load. When the load is acting at a point, so this is called the concentrated load. So this load is present at a single point. And this is the uniform distributed load. Here the uniform distributed load is present for some portion or throughout the span length. So this type of load is called the uniformly distributed load. This is called the varying distributed load. So here the load is varying from one end to another end. And this type of loading is called the concentrated couple. So this concentrated couple is acting at a point. And this is the distributed couples. The distributed couples is acting over a length. These are the different types of loads which are acting on the beams. The beam is subjected to vertical or inclined loadings. For beams with inclined loading, three conditions are to be satisfied for equilibrium. That is, summation of vertical force is 0, summation of horizontal force is 0, and summation of moment is equal to 0. Similarly, for beams with vertical loadings, two conditions are to be satisfied for equilibrium. That is, summation of vertical force is equal to 0 and summation of moment is equal to 0. Then coming to the types of supports. When a beam is subjected to inclined loadings, the various reactive components exist at various types of support. When a beam is subjected to inclined loading, and this is the roller support. So in roller support, the reaction is always perpendicular to the roller base. Whatever may be the loading. So the load may be the vertical or may be the horizontal loading. So always the support reaction is perpendicular to the roller base. And this is the hinge support. So in hinge support, when the load is acting in inclined manner, so in hinge support there are two reactions acting. So the one vertical direction and another one is horizontal direction. So there will be two reactions when the load is in inclined manner. If the load is acting on the vertical direction, so only there is one vertical reaction. Only there is vertical reaction, there is no horizontal reaction. This is fixed support. So in fixed support, there will be three reactive components: one vertical direction, one horizontal direction, and one moment. So when the load is acting in the inclined direction, and if the load is acting in the vertical direction, so there is no horizontal direction, only the vertical direction and the moment is acting. Two reaction components. This is the sliding support. So in sliding support, this is sliding support, and when the load is acting in the inclined direction, so here there are two reaction components, one horizontal direction and one moment. But when the load is in vertical direction, so there is no horizontal reaction, only the moment is acting when the load is acting in the vertical direction. Then coming to how to find out the static indeterminacy of beams. The static indeterminacy of the beam can be determined using the available conditions. So here two cases arise. So when the loading is in the vertical direction or when the loading is in inclined direction. So when the loading is purely vertical, there will be two statical conditions available. The first condition is summation of vertical force is equal to 0 and summation of moment is equal to 0. These two statical conditions are available. So in this case, the degree of static indeterminacy can be determined using this relation. The degree of static indeterminacy is equal to ds is equal to r minus 2. So r is the number of reaction components and 2 is the number of static equilibrium equations available when the load is acting in the vertical direction. Similarly, when a beam subjected to inclined loading, there will be three statical conditions available. That is summation of v is equal to 0, summation of h is equal to 0 and summation of m is equal to 0. So in this case, the degree of static indeterminacy can be determined ds is equal to r minus 3. R is the number of reaction components and 3 is the static equilibrium equations available. So ds is equal to r minus 3. The degree of static indeterminacy of the beam also can be determined using this relation. ds is equal to 3m plus r minus 3j, where m is equal to the number of members, r is equal to the number of reaction components and j is the number of joints. So using this formula also you can find out what is the degree of static indeterminacy of the beam when there is no internal hinge. Then coming to the example, how to find out the degree of static indeterminacy of the simple beams. This is the simply supported beam and here the load is in the vertical direction. This is one end is hinge and other end is roller support. When the load is acting in the vertical direction, so here the reaction at the hinge support, the vertical reaction, and the reaction at the roller support also the vertical direction. So there is no horizontal reaction at the hinge support. So h is equal to 0. So this case the degree of static indeterminacy can be find out using this expression ds is equal to r minus 2, because here you have to consider only the two static equilibrium equations. The summation of vertical force is equal to 0 and summation of moment is equal to 0. So ds is equal to r minus 2 and here there are two reaction components 2. So the degree of static indeterminacy is equal to 2 minus 2 is equal to 0. This is a determinate structure. Similarly, if the load is acting in the inclined direction, so at hinge support there are two reaction components, one vertical reaction and horizontal reaction, and at the roller support only the vertical reaction. Here there are three reaction components. In this case, the degree of static indeterminacy can be find out using this expression, ds is equal to r minus 3. Here the reaction component r is equal to 3, so ds is equal to 3 minus 3, this is equal to 0. So the degree of static indeterminacy is equal to 0. So the simply supported beam is a determinate structure. Then coming to the cantilever beam. So when the load is acting in the vertical direction, this is the cantilever beam. This end is fixed and this end is free. Here the load is acting in the vertical direction. So when the load is acting in the vertical direction, at the fixed support there is no horizontal direction, only vertical direction, and the moment is acting at the fixed end. In this case, the degree of static indeterminacy can be determined. This is equal to ds is equal to r minus 2. So here r is the two reaction component, this is vertical direction, and the moment r is equal to 2. So ds is equal to 2 minus 2, this is equal to 0. So the degree of static indeterminacy is equal to 0. Similarly, when the load is acting in the inclined direction at the fixed support, so there are three reaction components, one horizontal direction, vertical direction, and the moment. So here the degree of static indeterminacy can be determined by using the expression ds is equal to r minus 3. So here three reaction component at the fixed end, so r is equal to 3, so ds is equal to 3 minus 3 is equal to 0. So this is the degree of static indeterminacy, whatever may be the loading, vertical or the inclined loading, so this is equal to 0. So this is the determinate structure. Then coming to the prop to cantilever beam, when the load is acting in the vertical direction, this is the prop to cantilever beam. The one end of the beam is fixed and the other end of the beam is supported. And here the load is acting in the vertical direction. So when the load is acting in the vertical direction, at the fixed end there is no horizontal direction, only the reaction you have to consider the vertical direction and the moment. But at the supported end, so only the vertical reaction. Here there are three reaction components, r is equal to 3. So in this case, the degree of static indeterminacy can be find out using this expression, ds is equal to r minus 2, and here r is equal to 3, so ds is equal to 3 minus 2 is equal to 1. Similarly, when the beam is subjected to the inclined loading, at the fixed support there is horizontal direction, vertical direction, and also the moment. Three reaction at the fixed support, and here one reaction component, so the total reaction component is here equal to 4, r is equal to 4. So in this case, the degree of static indeterminacy can be find out using this expression, ds is equal to r minus 3, so r is equal to 4, 4 minus 3 is equal to 1. As the degree of static indeterminacy of this beam is 1, so this is statically indeterminate structure. The prop to cantilever beam is a statically indeterminate structure, and the degree of static indeterminacy is equal to 1. Using this expression also, you can determine the degree of static indeterminacy. So here you have to know the number of members, number of reaction component, and number of joints. So in this case there is one member, m is equal to 1, and 4 reaction component, 3 plus 1, 4 reaction component, and 2 joints, j is equal to 2. And using this value in this formula, you can find out what is the degree of static indeterminacy. ds is equal to 3 into 1 plus 4 minus 3 into 2, 3 plus 4 7 minus 6 is equal to 1. So the degree of static indeterminacy of prop to cantilever is equal to 1. Then coming to the fixed beam, this is the fixed beam. So here both ends are fixed or built in, and when the beam is subjected to the vertical loading, so this case there is no horizontal direction at the fixed support. There is no horizontal reaction at the fixed support. Only you have to consider the reaction, vertical reaction and the moment at both ends, both fixed ends. So this case, the degree of static indeterminacy can be find out using this expression, ds is equal to r minus 2, and here the total number of reaction component 2 plus 2 4, and the degree of static indeterminacy is equal to 4 minus 2 is equal to 2 when the load is acting in the vertical direction. Similarly, when the fixed beam subjected to the inclined loading, so this case at each fixed end there is horizontal reaction, vertical reaction and the moment. So this end there are 3 reaction components, and this end there are 3 reaction components. So the total reaction components equal to 6. So in this case, the degree of static indeterminacy can be find out using this expression, ds is equal to r minus 3. So r is equal to 6. So ds is equal to 6 minus 3 minus ds is equal to 6 minus 3, that is equal to 3. So the degree of static indeterminacy of the fixed beam when the loading is in inclined direction. So the degree of static indeterminacy of fixed beam also you can find out using the another approach, ds is equal to 3m plus r minus 3j. Using this expression you can find out what is the degree of static indeterminacy. But here you have to know the number of members, number of reaction component and number of joints. So here there is one member and the total number of reaction component is equal to 6, and the 2 joints j is equal to 2, and by using this value in this expression you can find out the degree of static indeterminacy. So 3 into 1 plus 6 minus 3 into 2. So 3 plus 6 9, this is 3 into 2 6, 9 minus 6, this is equal to 3. So this is the degree of static indeterminacy of the fixed beam. So this is also a indeterminate structure to 3 degree of static indeterminacy when the load is acting in the inclined direction. Similarly, coming to the continuous beam, when both ends are simply supported. Here this is 2 span continuous beam. So this is one span and this is another span, and here this end is hinge support, this is roller support, and this is also roller support. And here also when the continuous beam is subjected to the vertical loading, so here you can find out the degree of static indeterminacy using this expression, ds is equal to r minus 2. But as the loading is vertical direction, so at the hinge support, so there is no horizontal reaction component, only the vertical reaction you have to consider at the hinge support, and at the roller support, so there is only vertical reaction. So here the total number of reaction component is equal to 3, and the degree of static indeterminacy is equal to r minus 2, and r is equal to 3. So ds is equal to 3 minus 2 is equal to 1. So this is the degree of static indeterminacy when the load is acting in the vertical direction. The degree of static indeterminacy is equal to 1. This is also the statically indeterminate structure. Similarly, when the continuous beam subjected to inclined loading, so at the hinge support there is the horizontal reaction component and also the vertical reaction component, and at the roller support there is only the vertical reaction component. The degree of static indeterminacy you can find out using this expression, ds is equal to r minus 3. So here r is equal to 4, the ds is equal to 4 minus 3, so this is equal to 1. So this is statically indeterminate structure. So here also you can find out using the another approach, another formula, ds is equal to 3m plus r minus 3j. So here you have to find out the number of members, number of reaction components and the number of joints. When the load is acting in the inclined direction, in that case the number of reaction component is equal to 4, and the number of members is equal to 2, and the number of joints equal to 3. M is equal to 2, R is equal to 4 and J is equal to 3. So by using this value in this expression, so you can find out what is the degree of static indeterminacy. 3 into 2 plus 4 minus 3 into 3 is equal to 10 minus 9 is equal to 1. So the degree of static indeterminacy of continuous beam when both ends are simply supported, so that case this is equal to 1. So this is a statically indeterminate structure. So coming to the continuous beam, when one end of the beam is fixed and the other end is simply supported. So this end is fixed and this end is simply supported, and here this is the intermediate support. So the intermediate support and this support both are the roller support, and this case when the two span continuous beam subjected to the vertical loading, so this case at the fixed end there is no horizontal reaction component, only there is acting the vertical reaction component and the moment. But the intermediate support there is the vertical reaction component, and at the other end there is also the vertical reaction component. The total number of reaction component is equal to 4, and in this case the degree of static indeterminacy can be found out using this expression, ds is equal to r minus 2. So here the r is equal to 4 and ds is equal to 4 minus 2 is equal to 2. Similarly, when the two span continuous beam subjected to inclined loading, so this case at the fixed end, so there is horizontal reaction, vertical reaction and also moment, and at the intermediate roller support there is only vertical reaction, and at the other end roller support there is only vertical reaction. So here the total number of reaction component is equal to 5. This case the degree of static indeterminacy can be found out using this expression, ds is equal to r minus 3, and here r is equal to 5, so ds is equal to 5 minus 3, this is equal to 2. So the degree of static indeterminacy of this beam is equal to 2. So this is a indeterminate structure, and this also you can find out using the another approach, ds is equal to 3m plus r minus 3j. So here m is equal to number of members, r is equal to number of reaction components, and j is the number of joints. Here you have to count the number of members, number of joints and number of reaction components. Here there are 2 members, so m is equal to 2, and 3 joints, 1, 2, 3, j is equal to 3, and 5 reaction components. Here 3, 1, 1, 5 reaction components. R is equal to 5. Using this value in this expression, so you can find out what is the degree of static indeterminacy. So 3 into 2 plus 5 minus 3 into 3. So here 3 into 2 6 plus 5 11 minus 9. So this is equal to 2. So the degree of static indeterminacy of continuous beam when one end of the beam is fixed and the other end is simply supported. So here ds is equal to 2. Then coming to the continuous beam when one end of the beam is fixed and the other end is sliding. Here this is 3 span continuous beam. So this end is fixed and this end is sliding, and this is 2 intermediate support. So this intermediate support is roller support and this intermediate support is roller support. At the roller support always the reaction is perpendicular to the roller base, but at the fixed support and at the sliding support there is the reaction is depend on the loading condition. If the loading is acting on the vertical direction, so that case at the fixed end there is no horizontal reaction, only vertical reaction and the moment is acting, and at the sliding support there is also no horizontal reaction, only the moment is acting at the sliding support. So this case the degree of static indeterminacy can be found out using this expression, ds is equal to r minus 2. But here the total number of reaction component is equal to 1, 2, 3, 4, 5. R is equal to 5. So degree of static indeterminacy is equal to 5 minus 2 is equal to 3. So ds is equal to 3 when the load is in the vertical direction. Similarly, when the continuous beam subjected to the inclined loading, this case at the sliding support there is horizontal reaction component and there is moment. Similarly, at the fixed support there is horizontal reaction component, vertical reaction component and also moment. The total number of reaction component in this case is equal to 2, 3, 4, 5, 6, 7. So R is equal to 7. In this case the degree of static indeterminacy can be found out using this expression, ds is equal to r minus 3 and r is equal to 7. So ds is equal to 7 minus 3, this is equal to 4. So when the continuous beam subjected to the inclined loading and one end of the continuous beam is sliding and the other end is fixed, this case the degree of static indeterminacy is equal to 4. Also you can find out this using the other expression, ds is equal to 3m plus or minus 3j. So here you have to know the number of members, number of reaction component and number of joints. This is 3-span continuous beam, so 3 members, m is equal to 3, and the total number of reaction component is equal to 7, 1, 2, 3, 4, 5, 6, 7. Then the joint is equal to 1, 2, 3, 4, 4 joints, j is equal to 4. So degree of static indeterminacy is equal to 3 into 3 plus 7 minus 3 into 4. So this is equal to 16 minus 12 is equal to 4. The degree of static indeterminacy is equal to 4. 4, 4. Then coming to how to determine the static indeterminacy of a beam when there is present the internal hinge. In a beam, whenever a real hinge is introduced anywhere along the length of the beam, the moment at that point is equal to 0. If the internal hinge is present at any point in the beam, at that point the hinge provides one condition equations. So this is the beam, so this is the internal hinge. This hinge provides one condition of equilibrium equation. So this is the degree of static indeterminacy. You can find out ds is equal to 3m plus r minus 3j plus c. When there is no internal hinge, so that case the degree of static indeterminacy is equal to 3m plus r minus 3j. But if there is having the internal hinge, so this case the degree of static indeterminacy is equal to 3m plus r minus 3j plus c, where m is equal to number of members, r is the number of reaction components, j is the total number of joints, and c is the number of conditions equation available due to internal hinge. Now coming to this example, to determine the degree of static indeterminacy, so this is the prop to cantilever beam, and here there is having one internal hinge. This is the internal hinge. If the loading is vertical, this case at the fixed end there is vertical reaction moment, and here there is only vertical reaction. The total number of reaction is equal to 3, and r is equal to 3, and the number of member is equal to 1, and the number of joint is equal to 2. And here due to one internal hinge, c is equal to 1. So this case the degree of static indeterminacy is equal to ds is equal to r minus 2 minus c if the loading is in vertical direction. So r is the total number of reaction component 3 minus 2, and c is equal to 1. So the degree of static indeterminacy is equal to 3 minus 2 minus 1 is equal to 0. If the beam is subjected to the inclined loading, so this case at the fixed end, so there is horizontal direction, vertical direction and the moment, and the other end only vertical direction. So the total number of reaction component is equal to 4, and number of hinge is equal to 1. So the number of c is equal to 1, and the degree of static indeterminacy can be find out. ds is equal to r minus 3 minus c. So here r is equal to 4 and c is equal to 1. So 4 minus 3 minus 1 is equal to 0. So the degree of static indeterminacy of this type of beam is equal to 0. So this is a determinate structure. The degree of static indeterminacy of this beam also you can find out using the another approach, that is using this expression. Degree of static indeterminacy is equal to ds is equal to 3m plus r minus 3j plus c. Here m is equal to number of members, r is equal to number of reaction component, j is the number of joints, and c is the number of condition equation available due to internal hinge. So here number of member is equal to 1, and number of reaction component 1, 2, 3, 1, 4, and number of joints 1, 2, and number of condition equation available due to internal hinge 1. ds is equal to 3 into 1 plus 4 minus 3 into 2 plus 1. So this is 7 minus 7 is equal to 0. This is the determinant structure. Then coming to the next example, here this is the fixed beam, and here this is the internal hinge. If the fixed beam with internal hinge and subjected to the vertical loading, so this case at the fixed end there is no horizontal direction, only the vertical direction and moment is acting. So here there is moment and vertical direction, and here also there is moment and vertical direction. The total number of reaction component is equal to 4, and the number of hinge is equal to 1. So C is equal to 1. So the degree of static indeterminacy is equal to ds is equal to r minus 2 minus C. So here r is equal to 4 minus 2 minus 1. So this is equal to 1. Similarly, when the fixed beam with one internal hinge and subjected to the inclined loading, so this case, so at both ends there is horizontal direction, vertical direction and moment. So the total number of reaction in this case is equal to 6, and the number of internal hinge is equal to 1. So C is equal to 1. So the degree of static indeterminacy in this case find out. So the degree of static indeterminacy ds is equal to r minus 3 minus C. So here r is equal to 6 and C is equal to 1. So ds is equal to 6 minus 3 minus 1 is equal to 2. So the degree of static indeterminacy of fixed beam having with one internal hinge, so this is equal to 2. And also you can find out using the another alternative approach, using this expression ds is equal to 3m plus r minus 3j plus c. So here m is equal to the number of members, this is equal to 1, and the number of reaction component is equal to 3 plus 3 6, and number of joints is equal to 2, and the number of condition equation available due to internal hinge, this is equal to 1. So ds is equal to 3 into 1 plus 6 minus 3 into 2 plus 1. So this is equal to 9 and this is 7. 9 minus 7 is equal to 2. So here also you got 2, 2. Then coming to the static indeterminacy of two-span continuous beam with one internal hinge. So this is two-span continuous beam. So this end is hinge support and this is roller support, and the intermediate support is also roller support. And here when the beam is subjected to the vertical loading, so this case at the hinge support there is no horizontal direction, only vertical direction, and at the roller support there is only the vertical direction. So here you have to consider the 3 vertical directions. So r is equal to 3, and the number of internal hinge is equal to 1. So C is equal to 1. So degree of static indeterminacy is equal to ds is equal to r minus 2 minus C. R is equal to 3 minus 2 minus 1 is equal to 0. So ds is equal to 0. Similarly, the two-span continuous beam with one internal hinge and subjected to the inclined loading. So this case at the hinge support there is one horizontal direction component and there is one vertical direction component, and at the roller support there is only one vertical direction component. So this case the total number of reaction component is equal to 4. R is equal to 4 and the C is equal to 1. So, and the degree of static indeterminacy can be find out using this expression ds is equal to r minus 3 minus C. R is equal to 4 minus 3 minus 1, so is equal to 0. This type of structure is a determinate structure. You can find out the degree of static indeterminacy using the another approach and when subjected to the inclined loading. So here the degree of static indeterminacy is equal to ds is equal to 3m plus r minus 3j plus C. So here you have to find out what is the number of members, number of reaction component, number of joints, and number of condition equation available due to internal hinge. As the loading is in inclined direction, so at the hinge support there are 2 reaction components, one horizontal direction and one vertical direction component, and at the roller support there is only one vertical direction component. So the total number of reaction component is equal to 4 here, and 2 members m is equal to 2 and joint 3 and C is equal to 1. Then find out ds is equal to 3 into 2 plus 4 minus 3 into 3 plus 1. So 10 minus 10 is equal to 0. So here you got the ds is equal to 0, and here also you got ds is equal to 0. So the degree of static indeterminacy of this type of beam is equal to 0. So this is a determinate structure. Then coming to this example, here this is two span continuous beam, one end is fixed and other end is simply supported, that is the roller support, and at intermediate also roller support, and here one internal hinge is present, and you have to find out what is the degree of static indeterminacy when the beam is subjected to vertical loading or inclined loading. So when the beam is subjected to vertical loading, at the fixed end there is no horizontal direction, only have to consider the reaction, vertical direction and the moment, and at the roller support there is the vertical reaction. So the total number of reaction component here is equal to 4, and C number of hinge 1, so C is equal to 1. So the degree of static indeterminacy is equal to ds is equal to r minus 2 minus C. 4 minus 2 minus 1 is equal to 1. So ds is equal to 1. Similarly, when the beam is subjected to inclined loading, so that case, so at the fixed end there is 3 reaction component, one horizontal reaction, one vertical reaction component and one moment, and at the roller support only vertical reaction component. So the total number of reaction component in this case is equal to 5, and number of hinge is equal to 1, C is equal to 1, and the degree of static indeterminacy ds is equal to r minus 3 minus C. R is equal to 5 minus 3 minus 1 is equal to 1. So the degree of static indeterminacy of this type of beam is equal to 1. Also you can find out by using the alternative approach when subjected to the inclined loading. So here at the fixed end there is 3 reaction component, horizontal, vertical and moment, and at roller support only vertical. So total number of reaction component is equal to 5, and number of members this is equal to 2, and number of joint 3, and C is equal to 1, and using this expression you can find out what is the degree of static indeterminacy. ds is equal to 3m plus r minus 3j plus C. ds is equal to 3 into 2 plus 5 minus 3 into 3 plus 1. So this is 11 minus 10 is equal to 1. So the degree of static indeterminacy of this type of beam is equal to 1. So this is a statical indeterminate structure. Then coming to another example, here this is two span continuous beam, and one end is having the sliding support and another end is fixed support, and this is the intermediate support, roller support. One internal hinge is present here. Here also you have to find out the degree of static indeterminacy when the beam is subjected to vertical loading or inclined loading. So when the beam is subjected to vertical loading, so at the sliding support there is no horizontal direction, and at the fixed support there is also no horizontal direction, only vertical direction, and the moment is acting at the fixed support, and at the sliding support only moment is acting, and at the roller support there is only vertical reaction component. So the total number of reaction component is equal to 4, and one internal hinge, so C is equal to 1. The degree of static indeterminacy can be found out using this expression, ds is equal to r minus 2 minus C. So ds is equal to 4 minus 2 minus 1 is equal to 1. Similarly, when the beam is subjected to the inclined loading, at the sliding support there is a horizontal direction and also there is moment, and at the fixed support there is a horizontal direction, vertical direction and a moment. So this case the total number of reaction component is equal to 2 plus 1 plus 3, 6, and the number of hinge 1, so C is equal to 1, and the degree of static indeterminacy can be found out, ds is equal to r minus 3 minus C. 6 minus 3 minus 1, this is equal to 2. And also you can find out by using the alternative approach using this expression, ds is equal to 3m plus r minus 3j plus C. So here the number of members 2, and the number of reaction components 2 plus 3 plus 3, 6, number of joints 3, number of condition equation available due to internal hinge 1. Then by using this value in this expression, you can find out ds is equal to 3 into 2 plus 6 minus 3 into 3 plus 1. This is equal to 12 minus 10 is equal to 2. And here also you got 2 when the beam is subjected to inclined loading. 2, here also you got 2. So this is the degree of static indeterminacy of this type of structure. Now all are clear how to find out the degree of static indeterminacy of different types of beam with internal hinge or without internal hinge.